Hello everyone, so let's talk about the unique path too. So you are given an n by n matrix, and then you need to return the number of possible unique path for this matrix. And then in the matrix, there's actually the stone, which is going to represent 1 in the grid. And then you need to know like if you traverse all the way from the top left to bottom right, if you see the stone, you cannot actually go through it. So you need to know like how many unique paths that can go from the top left to bottom right without going through the stone. So in this question, you can only going from top left, and then go all the way to the top right, and go all the way to the bottom right, right? And then this is one path, and the other path is this, right? So the total number is 2. So again, this question is supposed to be easy. So we can use in the same grid, right? And just keep updating. So just for example, I'm going to just copy and paste the entire grid. So again, you are traversing from the top left, right? And then you need to go all the way to the bottom right, right? And then the stone is going to be represent 1. So this is the default grid, right? The default grid. And then we need to just keep updating our metric based on the number in the cell, right? So I'm going to just give you the hint. Here's the note. So if you can traverse from for the cell, it's going to be represent 1, and this is going to be yes, and 0 is going to be no, right? So again, this 1 doesn't represent the stone, but they actually look like they are actually the same value, but they are not the same meaning, right? This is like when you're traversing, updating the grid, this is the number of paths, and the number 1 for the default value is actually the stone. So again, like we can update in the cells for right now, right? So since this is a 0 and this is what, you can definitely go through it, right? So this is going to be a 1. So I'm going to erase. I'm going to say 1, and then I'm going to traverse the next one. So if this is 0, and then the previous one is actually 1, which means what? This is one path, and the 0 represent what? The 0 represent there's no stone, right? So you will keep updating this to 1, and then the next one is going to be exactly the same thing, 1, and then for the column update, you only update the row 0, and then you need to traverse the number of column for row 0, right? And then for the column 0, you need to update the number of rows in the matrix. So again, it's going to be the same idea. If the previous equal to 1, and then the current equal to 0, you need to update to 1, right? So the previous one is 1, which represent one path, and then the 0 in this case is actually represent no stone, right? So you represent 1 in this case, and this is going to be exactly the same thing. All right. So now we need to traverse this little grid, right? So the 1 and 0 are still represent stone or no stone, right? But in this one, the 1 is actually represent a path. So again, we need to update the grid for the path, right? So at the end, we can just return the last cells, right? So for this one, right? Since this is a stone, so it's definitely going to be what? Definitely it's going to be 0. So this color 0, right? And then I'm going to traverse from row to row. per row, column by column. So the next one is going to be this one, right? So I'll update this. So this is going to be 1. Why? Look at this. Like if this is a stone, you can only go from here to here, right? You cannot go from here back to here and then come back, right? This doesn't work, right? So you can only what? Go from your top, right? And then the exactly the same thing for here. Since this is a stone, you can only go from here to here, right? So this is 1, right? So here's the tricky part. So what do you think about this one? This is going to be 2, right? I mean, we already know it's 2, but why the answer is 2? You need to plus the top and plus the left, right? So the number of the path from the top and the number of the path from the left, this will be what? The value, the number of possible way you can achieve from Arthur's place, right? So again, this is pretty simple. So you are going to say grid ij, right? Doesn't matter which j you are looking for. So it's going to be what? Left plus top, right? So if this is not 0, right? If the cells is not 0, you can do this. If the cells is actually 0, I mean, if the cells is actually stone is represent 1, right? You are going to assign 0. If ij is actually equal to 1, you need to assign set to 0. So again, the 0 by default value for the grid, 0 and 1 doesn't mean the path, but when we're updating the grid, the 1 and 0 represent the path. So this is pretty much a solution. And then we only update the current metric, current grid, right? So we don't actually take the memory, the space complexity will be constant. So here we go. So let's start coding. And we don't actually need to look at this. So I'm going to say int, unrepresent, I'm going to just say grid. The name is too long. So grid at length, and it's going to be what? This is represent row, this is represent column, and at the end we just have to return the last one, right? The bottom right? We started from what? Top left. So if the top left is a stone, right? The base case is going to be what? If the top left is going to be a stone, represent 1, you just have to return 0, right? If not, if the top left is not a stone, we can just assign the cells to 1, which means 1 path. Alright. So now I'm going to traverse from the index 1 for the column and index 1 for the row to update my row and column. Just for the first row and first column. So I equal to 0, I less than n, I plus plus. And I'm going to just represent grid. Grid I is 0, right? So I'm going to check, right? The previous one is 1 path, and the current one is no stone, right? No stone. And then you represent 1, else you represent 0, right? And then exactly the same thing for the column. Grid I, j. Actually this is 0, right? And this is going to be exactly the same thing, grid 0, j minus 1. The previous one represents 1, which means represent 1 path, and then the current one represents 0, which means there's no stone. Then we update here 1 and 0, right? Alright, so now we can actually update our metric. So we can start it from 1 to 1, right? And then if the grid aij is equal to 1, which means this is the stone, then the number of the path is actually equal to what? You set it to 0. Anything else, you can update your grid to what? Left and top, right? So grid I minus 1 j plus grid I j minus 1. And this is pretty much the solution. So let me run it. Alright, so I made a mistake. So this is all of wrong somehow. Oh, you have to start it from 1, sorry. This is because we already assigned the 0, right? We don't care about the 0 anymore. We started from 1, right? Sorry for a mistake, and then let me run it. Right. And I hope I pass the entire test case and submit. Alright, so let's talk about the time and space. For the time, right? Let's talk about the time first. This is all of n, right? This is all of n, and this is all of n times n, right? So the worst case is going to be this one, right? And then for the space, this is a space, and the question given is a space. But in this function, we don't allocate any other memory, so I would say it's constant, right? So again, my quick note for the solution is this: all of n times n for the time, constant for the space, and then n represent the grid, and then this is a solution. So if you have any question, leave a comment below, and then I will talk to you later.